stars. Here we go. All right. This next section focuses specifically on right triangles, on right triangle trigonometry. Okay, so let me bring you back to a little bit of geometry. Okay, just a little bit, Okay, here, go ahead, sir. Here is an angle on the coordinate plane, right? Notice that the initial side is on the correct side, the positive x-axis. This is the initial side. What's the other side called? Starts with a T? Terminal side, because where the angle ends, right? So you are looking from the point of view of that angle, all right? So angle theta is right there in the corner where the origin is. Okay. Bless you, my love. Here we go. In geometry, before I show you this, right underneath there's a lot of room. In geometry, you heard this three-letter word. So, three-word word. Yeah. So, ka, toa. Soka-toa. Right. S, the so stands for sine is opposite over hypotenuse, right? That's what the so part means, opposite over hypotenuse. C stands for, yeah, cosine, which is adjacent over hypotenuse. And tan is opposite over adjacent. Oh, you're so smart, Angelina. Here we go. Opposite over adjacent. Now that depends on what perspective you're looking at. So that's why it's important to draw the triangle correctly when you're setting it up, so that way you have the angle that actually refers to it, right? So you know how we said that sine is y over r? Well, it's because from this angle, the y is the opposite and the r is the hypotenuse. It's the hypotenuse, right? So it's all connected. Sine is y over r because it's opposite of the hypotenuse from that reference angle. Yay. Yay. On your notes, you already have all these things. So it tells you the sine is opposite over hypotenuse. You got cosine and tangent, right? Okay. And then from the other perspective, if you want to find secant, cosecant, and cotangent, you just flip sines, cosines, and tangents. So cosecant would be hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. Yay? Okay. Before we move on with the rest of the notes, just put it to the side again. I just want to focus on this part right here. Bless you. I'm going to pause the video real quick, and we're going to do a little activity. Okay. So all of that just to bring us to this point. Here we go. Oh. There it is. Okay. Take a look at this triangle here. Yay. All right. Remember to adjust your point of view as necessary. So, Jalish is standing at D. Right. Jalish is over here. Yay. Yay, math. All right. To find the sine of where Jalish is standing, sine is the so part, so opposite over hypotenuse. What's opposite from Jalish? The 36. The 36. Yes, here we go. And the hypotenuse would be 85. Okay. Another one of these ratios is 36 over 85. Right. There's going to be another one. It's going to match up. From the cosine of D, from Jalish's perspective, the cosine is the adjacent over hypotenuse. So, yeah. 77 over 85. Yay. And last but not least, tangent. There you go. 36 over 77. Yeah? There you go. Okay. All right. So, the second angle, the second acute angle over there is E. Is it 36 over 85 for tangent? You got it? Yeah, okay. Yeah, because the tangent doesn't have the hypotenuse. True? Okay. Excellent, excellent. All right, here we go. Peter is at E. Peter Parker is at E. Here's Peter, right? So, from Peter's perspective, this is a bit much, Peter. This is a bit much. There's your web. All right, there's Peter Parker over there. Yay. From Peter's perspective, his sine is going to be 77 over 85. What? The other 77 over 85 was the cosine of D. Right. So depending on the perspective, you're going to get the same ratios, or the same numbers for different ratios. Yay? Okay. His cosine is 36 over 85, which matched the sine of D. Yay? I know, it's insane. It's constant. Right? And then tangent of E is 77 over 36. These two are flipped. So you could say that the tangent of E is the cotangent of D as well. Okay. There's like a lot of things going on right now. So to try to keep all these relationships in mind. Really quick, just as a recall, if you add angle D and angle E together, what is it supposed to add up to? 90. Right? In other words, they're the complementary angles. Yay? Okay? Notice that the sine of one was the cosine of the other and vice versa. And then this one is equal to the cotangent of D. Yay? Okay. That gives us the two relationships that we're looking for. So, for example, in this one, that's on the back page. Yay? Okay. Talking about cofunctions. All right. So the sine of A is A over C. That is the same thing as the cosine of B. Yeah. The sine of A is the same thing as the cosine of B. Yay? Right? Just looking at the two smaller angles. The tan of A is the same thing as the cotangent of B, of the other angle. It's the flip of the other angle. Hello! Hello! Yeah? And the secant of A is the same thing as the cosecant of B. Yeah. Right? Again, A and B, in this case, I switched up the letters. A and B are the two acute angles. They add up to 90. So you can solve for one of the angles just by subtracting it to the other side. In this case, we just solved for B. Yay? So in other words, sine A is the same thing as the cosine of B. Yay? Which, since B is just 90 minus A, it's the same thing as the cosine of 90 minus A. Yay? So bringing these two together with the transitive property, you can say that sine A is the same thing as the cosine of 90 minus A. Yeah. And that's where these come from. So sine and cosine are cofunctions, tangent, cotangent are cofunctions, and secant, cosecant are cofunctions. Basically, if you have the angle, subtract it from 90, and then you can get the cofunction of the other angle. Okay, all right. They're not buying it yet. Okay, here we go. As I said, sine and cosine are cofunctions, so the following identities are true. This is the one we just wrote. Sine A is equal to cosine 90 minus A. right? Remember that sine and cosine are cofunctions, so this one is going to say cosine A equals, yeah. Oh my gosh, yeah, it's sine 90 minus A, which is the cosine, which is the sine of B. Remember, B is 90 minus A, so it just be the sine of B. Yay? Yay. All right. So for cosecant and secant, so cosecant A is equal to secant 90 minus A. Same thing for secant to cosecant. All right. Yeah, no worries. Yay? And then the other relationship is tangent and cotangent. Okay? So if I were just to block off three relationships, sine and cosine are cofunctions. Yeah. Woo. Hello. Ah, yeah. Go to Christmas. Here we go. So secant and cosecant are cofunctions. And last but not least, tangent and cotangent are functions. And then are cofunctions. In other words, they have the same value because they're just the flip of each other. You okay? Good? Okay. All right. This might seem like a really tedious way to do something very simple, but do realize it's very simple. It's really simple. You're just subtracting the angle from 90. From 90. That's it. So, here we go. Anyone still copying? We good? Okay. To find the cofunction of sine of 9 degrees. Yay. What's the cofunction of sine? Cosine, right? So to find the cofunction of sine, that's the same thing as the cosine of, take away 9 from 90. So 90 minus 9. Catch page. I know, it just looks tedious. It looks tedious. 90 minus 9 is 81. If you don't believe me, turn on your calculator. Yeah, turn on your calculator. There you go. Do you not have a calculator? Go get one. Go get one. Here's how you check to see if you're right. I mean, it's not that hard, but I mean, you know. Miss Fleck, we're not allowed to use a calculator on this test. I know, but we're learning right now. It's okay. It's okay. It's crazy, isn't it? All right. Your calculator should be set in degrees. If it's not, make sure it says DEG at the top. Does it say DEG at the top? Yay. Okay. Josh, you and me. Here we go. Go to mode. And then see where it says radian. Make sure degree. Okay, excellent. All right, here we go. So, depending on how you type in your calculator, if you have one of the TI-80 something calculators, you have to type in the angle first and then hit sine. So to do sine of 9, you hit 9 and then hit sine. For mine, oh goodness. Yeah. From here. Okay. All right. There it is. Okay. So for mine, I just hit sine and then 9 degrees. Did you get 1.5 something, 0.15 something? Excellent. Now type in the cosine of 81. Right? And without hitting enter, what do you think it's going to be? The same thing. It's the same thing. Because they are cofunctions. Okay. Oh my goodness. Here we go. Covariables. Yeah. That's it. So basically, we found the same value for two different functions. Yay. Yeah. And again, 9 plus 81 is 90. I'm like really pushing that one on. Here we go. Yeah. All right. So, what is equal to the cotangent of 76? You think about it. cotangent of 14 degrees. Exactly. It's the same thing. Yay. What is equal to the cosecant of 45? Wow. That's it. That's the same thing as the secant of 45 degrees. How do you feel? It's good. Okay. You need some algebra testing, I think, is what you need. Okay. Here we go. Here's some algebra testing. What? Okay. All right. Here we go. Now that we have a good idea on how to find like equivalent parts, right? You can solve something like, what? What is this? What is this? Yeah. Yeah. It looks horrible. It looks horrible, but it's not. It's not. Here we go. In order, ready? In order for tangent and cotangent to be equal, their angles must add up to 90. That's it. In order for this to be true, their angles have to add up to 90. The angles in this case is an expression. So this plus this have to add up to 90. That's how you set up this problem. Yeah. Okay. Here we go. So theta minus 8 plus 4 theta plus 13 needs to equal 90 in order for this to be true. That's it. Combining like terms, you have 5 theta plus 5, is that right? Is equal to 90. Is that no? Is it minus 13? You're right, it is minus 13. My bad. It's minus 13. So what is it? Negative 21. You know what? That's not going to be pretty. Change it to plus 13. Sorry about that. It'll work. It's just going to be a fraction, and I don't like fractions this time. This time. Yeah, so change it to a plus. I'm sorry. Yeah. Okie dokes. We good. So now we're back to 5 theta plus 5. 5 theta is equal to 85. So theta has to be, yeah. Is it 17? I believe it. I believe it. That's it. But, I mean, right? So in other words, the angle that would make this true is 17 degrees. That's it. Did I lose anyone? Mer? Very good. The key was to recognize that in order for it to be true, for the cotangent to equal tangent, their angles have to add up to 90. Thank you, Anthony. Yay? I know. You're awesome. All right. Here we go. Last one, then you're on your own. No, last one together, then you're on your own to do homework. Oh. Yeah, which you are going to turn into me whatever you do today. That's it. No, no more. Here we go. I got you. Oh, goodness. Here we go. Secant and cosecant. Right. In order for this to be true, for secant to equal cosecant, their angles must add up to. Okay, here we go. So 5 theta plus 14. Do we have the same thing on our paper too? Plus 2 theta minus 8 equals 90. Yay. 7 theta plus 6 equals 90. 7 theta equals 84. Yay. It's 12. It's a little old 12. 12 degrees is the degree that would make that a true statement. Yay? All right. You can do this. Here we go. It is really this simple. If you have any questions, make sure you ask. The assignment for tonight should be on your paper. Right? Is this the same stuff? 1 to 36. Yeah. Yeah. So 3 to 36. is all. Right? The cofunction, the angles will equal 90. Yes. And the cofunctions that equal each other are sine and cosine, tangent, cotangent, secant, cosecant. Yay? Yes, Mr. Anthony. Yeah.